factor trinomials of the form x squared plus bx plus c. That is in the abstract form, in algebraic form, and we'll be looking with them in numbers, but I just want you to see the general form first of all. Okay, in the previous topics that we have covered, we learned how to multiply binomials. That's point one. For example, if we have and this is just our recap, okay, multiplying binomials. And the reason why I'm recapping this, so that you could remember that this is what we're gonna be, this is also involved in this topic here that we will be doing. So if we have x plus 2 and x plus 3, what happens here is that we will multiply this by this and this by this. Remember the FOIL method, okay? And then this term by this and this term by this. So we do that. X times x give us x squared. X times 3, 3x. 2 times x, 2x. 2 times 3 will give us 6. That gives us a result of x squared plus, add these two, 5x plus 6. That is what we have been doing. To factor trinomials now, which is here, okay, we will reverse the multiplication process. So to factor this out, we're going to go the opposite direction to determine what factors we were multiplied to obtain this value. Okay, since the product of the two binomials is often a trinomial, many trinomials factor into the product of two binomials. Okay, when we factor this out, it becomes this way. So multiplication given the binomial factors, we find the trinomial. Okay, factoring given the trinomials, okay, we find the binomial factors. We will now consider how to factor trinomials of the form x squared, ax squared plus bx and c, where a is called a leading coefficient, right? But for right now, let's work with the trinomials of this form. All right, so we will be dealing with when we have an EA at the front. In the meantime, the value here is a 1. So let's go to develop a method of the form. So develop a method of the form x squared plus bx plus c. We multiply the two of them, and then we'll see what then happens. So let's try another value. Consider that we have x plus 4 and x plus 5. Let's look at step by step and see if we could find what is actually happening. We're going to use the FOIL method. X times x, so we have x times x, and then we have x times 5, so that's plus x times 5, and then we have 4 times x, 4 times x, and then we have 4 times 5, 4 times 5. When we end up the next step, this gives us x times x, x squared plus 5x plus 4x plus 20. Notice what we got, all right? Then the next step will be x squared plus 9x plus 20. Now here, this is very important. This is the first term. This is the second term. And this is the last term of the trinomial. The result has 3 terms, if you notice. So we multiply this out, we end up with 3 terms. So we can see from this, okay, and these are 3 pointers that needs to have been observed here. So 3 pointers. The first term, which is x squared, is the product of x and x. Notice that this first term is a product of this x times this x, the first 2 terms. Okay, next pointer. the last term 20 is the product of 4 and 5. Notice the last two terms multiplied. 4 times 5 give us 20. So the last term is the product of the last two terms. And then now the coefficient of the middle term 9 is the sum of 4 and 5. Notice that shortcut, right? If you say x times x, you get x squared, and then go to the n. The n will be 4 times 5, which gives us 20. And then this middle term comes by saying 4 plus 5 times x, which gives us 9x. And that's what this is saying. The coefficient of the middle term 9 is the sum of 4 and 5. So to get this coefficient here, just simply add these two terms, all right, the two last terms in each one of them. So that's how we work that out. Now let's try our next example of that same form. So we have now example factor x squared plus 5x plus 6. Our strategy is that we will assume that x squared plus 5x plus 6 is a product of two binomials. So we have to assume that for right now that it's a product of two binomials, obviously, if it can be factorized. And we will use a systematic method to find their terms. Why? Because since the terms x squared plus 5x and 6 do not have a common factor across other than 1, the only option available to try to factor is as the product of two binomials. They cannot all be divided by 1. Solution. Since the first two terms of the trinomial x squared, the first term of each trinomial factor must be x. Okay? So to fill in the blanks, we must find two integers whose product is 6 also, and whose sum is 5. Remember, to get this first term, we multiply the first two terms of the binomials. Right? And then we multiply the last two terms to end this. And then those two numbers which were multiplied, they need to be added to give us the middle term, in other words. All right? So then, this is what we are going to do. We will take now x squared plus 5x plus 6. All right? Factors of 6. Let's see, what are the factors of this 6? Because we already know that x times x equals x squared. So we know what's the first term. So we can put here our brackets, and we could put x times x. That will give us our first term. But we need to choose our values carefully for the other part, so we can get the 6 as a product here and the sum here. So let's put it on the side. Let's say that the factors of 6. What are the factors of 6? Well, it's 1 times 6, 2 times 3. The sum of factors of 6. What are the sum of the factors of 6? Well, 1 plus 6 will give us 7, and 2 plus 3 will give us 5. So this is the right combination, not that one there. Okay? So this is to find which two numbers when multiplied will give us this last term, and when you add those two numbers, you will get the middle term, the middle coefficient. Therefore, we can say that the second part will now be 2 plus 3, 2 plus 3 there. Or you could go 3 here and 2 here. It doesn't make any difference. You will get back the same answer. Okay? Now, as a very successful tip that I must give you here. When factoring trinomials, okay? Note this carefully. When factoring trinomials, the binomial factors can be written in either order. So we could have put 3 here and 2 here. All right. Okay, so that's what that means. So just a word. I'm giving you just a word of advice there. All right. So let's try our next one. The same method. Next example, we go here. So we have factor, and this is an example. We have y squared plus 7y plus 6. Let's look. Factors of 6. Factors of 6. Well, factors of 6 are 1 times 6, 2 times 3. Those are factors which will give us 6. And now the sum of those numbers will be 1 plus 6 will give us 7, and 2 plus 3 will give us 5. So the correct one will be 1 plus 6. So our solution here will now be, well, we know that the first term is gotten by saying y times y. So we put that there, y, and we put 1 plus 6 there, or 6 at the first and 1 second. It doesn't make any difference there for us to put it at the front or at the back. Okay? Try our next example. If you notice, all of our examples at this point will have been positive. We're going to try now with some negatives. I have factor, and let's say I have p squared minus 7p plus 12. Okay, a negative sign. Very important, you need to remember that a negative times a negative will give us a positive. A negative times a positive will give us a negative. You need to remember those rules. We will assume first of all that that this is a product of two binomials, that this came from two binomials, and we will use a systematic approach to find their terms. Why? Since the terms do not have a common factor other than 1, the only option available is to try to factor it as a product of two binomials. That's the point. Solution. Since the first term of the trinomial is p squared, the first term of each binomial factor must be p in this case. To fill in the blanks, we must find two integers whose product is 12 and whose sum is negative 7. Now here you have to be careful, you need to remember the rules of integers. So let's see. I have now, let me write it here, p squared minus 7p plus 12 equals. I know for a fact that this first term here will be p times p. So we finish with that part. The only question now is this negative 7 and 12. Remember what we said. We're going to find the factors of 12. So we have 1 times 12, 2 times 6, 3 times 4. Those will give us 12. Alright? Let me zoom in a little bit more in there. So we have here 12, here 6, and then the sum of those combinations will be 1 plus 12 will give us 13, 2 plus 6 will give us 8, and 3 plus 4 will give us 7. Now, the question is, how can we get this middle value to be a negative 7? Because we want a negative 7 in the middle. We don't want a positive 7. Well, if I had said negative 3 plus a negative 4, I end up with a negative 7. So that's good for us to get the negative 7. And a negative 3 times a negative 4 will give me a positive 12. Let's go over this piece here again. We know that the first term is actually p times p. That is okay. That's very straightforward. Now we go for the factors of 12. because we know that this last term is the product of two numbers being multiplied. So we now say 1 times 12, that's 12. 2 times 6, that's 12. 3 times 4, that's 12. No way you can combine 1 and 12 to get 7. You cannot say 1 minus 12 or 12 minus 1 to give us 7. There's no way you can combine 2 and 6. If you say 6 minus 2 or 2 minus 6, you cannot get negative 7. But if you say negative 3 minus plus negative 4, then you get with a negative 7. And so we choose that. So then 4 and the 3 needs to be negative, so we put here negative 3 and here negative 4 for that combination. So therefore the best option will be 4 plus 7. Okay, so that's how you get that one there. So let's try our next example just like it. We have factor y squared minus 5y plus 6. Okay, we're going to be factoring them out. We go first of all with the 6. Factors of 6. Those are 1 times 6, 2 times 3. The sum of these numbers will now be 1 plus 6 will give us 7. 2 plus 3 will give us 5. Okay? Now, let's see how this works out. We know that the first term, y, we put our brackets, we know that this is y times y. We know that for a fact. That is finished. We know that this last term is the result of the product of two numbers. This you could get by saying 1 times 6 or 2 times 3. That will give us 6. However, 1 plus 6 will not give us the middle term, which is negative 5. And if you had said here 6 minus 1, that's going to give us a positive 5. But if I say 1 minus 6, I now end up with a negative 5. But a 1 times a negative 6 will not give us a positive 6. Why? Because a negative times a positive will give us a negative. So therefore, I need that combination that when I multiply those two selected numbers, I get back a positive value. So if I say 2 plus 3, that gives me 5. And if I say 2 times 3, I end up with 6. So therefore, if these two terms here are negative, then I can get a positive 6. So negative 2 times negative 3 will give me a positive 6. And like how the rule says, if you add these two terms, a negative 2 plus a negative 3, that's a negative 5 times y, we get a negative 5y for the middle term. So that is how we're going to be working out these terms here, right? So then let's go a little much more in depth. The factors of 6 were as follows, right? 1 times 6, 2 times 3. We're going with a different approach now. We can also get the factors of 6 because remember we will want a negative value in front. So if we were to say negative 1 times negative 6, we get positive 6. If we say negative 2 times negative 3, we end up with a positive 6 still yet. Okay, so those are combinations. Now, which one of them when combined will give us a negative 5? Well, this will give us negative 1 plus a negative 6. That will give us a negative 7. Negative 2 plus a negative 3. That will give us a negative 5. So therefore, that is our best option there, right? So that should not be that difficult for us to work out. Now remember, this is the trinomial x squared plus bx plus c, right? We're going to have other examples where the negative is no longer in the middle here, but we're going to move the negative to this last term, okay? Concept is the same thing, just a slightly different approach that how to go about in solving it. So let's move. Remember, where's the negative, all right? So we're going to the next one. This next factor, this next problem has to say a squared plus 2a minus 15. Okay, we will assume that a squared plus 2a minus 15 is the product of two binomials because that's what we're solving for. Since the terms a squared plus 2a minus 15 do not have a common factor, they don't have anything common other than the value 1, the only option available is to try to factor out as the product of two binomials. Alright? Solution now. Since the first term of the binomial of this trinomial is a squared, remember the first term is a squared, the first two terms of the binomial factor must be a. We know that for a fact because when we go backwards, so you can say here now the first term will be a times a, so you get a squared. All right, then to fill in the blanks, we must find two integers whose product is negative 15 and whose sum is positive 2. So we go ahead and we start to find factors of 15. So factors of 15, they are, right, 1 times negative 15, that gives me a negative 15. 3 times negative 5, that gives me a negative 15. 5 times negative 3, that gives a negative 15. Positive 15 times negative 1, that gives a negative 15. Now the sum, let's see, 1 plus negative 15, that gives a negative 14. 3 plus negative 5, that gives a negative 2. 5 plus a negative 3, that gives us a 2. 15 plus a negative 1, 14. So which one of them gives us a positive value for the middle? 2, which is this 2 here. And when we multiply these two values, we get a negative 15. So therefore, the best combination will be a positive 5 and a negative 3. So we put here positive 5 and negative 3 there. Let's go over it again. I gave you a squared plus 2a minus 15. Remember, now the negative moved from the middle to the outside. We find the factors of negative 15. Not just 15, but negative 15. The only way you can get a negative when you multiply to get this last term is to say 1 times negative 15, that's negative 15. 3 times negative 5, that's negative 15. Positive 5 times negative 3, that's negative 15. Positive 15 times negative 1, that's still negative 15. Now add them to get the sum so that can give us our middle coefficient. 1 plus a negative 15, negative 14. 3 plus a negative 5, negative 2. 5 plus a negative 3, positive 2. Aha! That's what we want. We want that positive 2. And we want that when we multiply them, we get a negative 15. So therefore, this was the best option, 5 and negative 3. You could have put negative 3 in the front and positive 5 at the end. It doesn't make any difference. It is still the same result. Okay? So now let's go to our next example. This next example now will now have negatives almost in the whole trinomial. So you have z squared minus 4z minus 21. Okay? First step, factors of 21. Of negative 21. Okay? So you put here now 1 times negative 21, that's negative 21. 3 times negative 7, that's negative 21. 7 times negative 3, that's negative 21. And 21 times negative 1, that's negative 21. Now, the sum of those numbers, of those possible combinations, sum of, okay, of factors of negative 21. 1 plus negative 21, negative 20. 3 plus negative 7, negative 4. 7 plus negative 3, positive 4. 21 plus a negative 1, 20. So which one of them gave us a product of negative 21 and also gave us a sum of negative 4? If you notice, we got a 4 here, negative 4 here. And the only product which will give us and the negative 21 will be 3 times negative 7. And when you add them, you get a negative 4. So therefore, this will be the best combination. What's the first term in it? Well, it will be simply z. Why? Because we know that this first term comes from the product of these first two terms. And so we put 3 minus 7, or negative 7 plus 3. That's our solution for that one there. All right, let's try our next example. Factor q squared minus 2q minus 24. Let's go with the factors of 24. Factors, and not just 24, negative 24. 1 times negative 24, 2 times negative 12, 3 times negative 8, 4 times negative 6. Those are the factors to get negative 24. Now, the sum of the factors. So we end up now and say 1 plus a negative 24, negative 23, 2 plus a negative 12, negative 10, 3 plus a negative 8, negative 5, 4 plus a negative 6, negative 2. So which one of them give us the sum of this coefficient? This one here. And when we multiply these two, we get a negative 24. Therefore, the solution will be, well, the first term in this will be q. So we put q times q and then bring the plus 4 and negative 6, and we finish with that particular problem there. So notice it's not that difficult, okay? So, and now I want you to see that patterns can be helpful when factoring trinomials. You notice this had signs, all right? So let me give you a note on that before we proceed to two more examples that can help guide how to solve it. So factoring trinomials whose leading coefficient is 1. Whose leading coefficient is 1. Right? Very important. Those are ones which we are doing. So to factor x squared plus bx plus c, find two integers whose product is c, which we did, and whose sum is b. That's what we did. We multiply, we end up with c. We add those two values, we end up with the b. So pointer 1, if c is positive, okay, the integers have the same sign. 2, if c is negative, the integers have opposite signs. We saw that in our problems which we did a while ago. So when factoring trinomials of the form ax squared plus bx plus c, where a is equal to negative 1, we will begin by factoring out the negative 1. Okay, that's a key point right now. But for right now, we're dealing with the ones without the a. So just remember that. So we're going now a little bit now. So if this had anything other than just negative, then you will work it a different method, right? But same concept. So let's try some more examples. Consider that I tell you now, factor negative h squared plus 2h plus 15. Okay, we will factor out the negative 1 first of all right, and then factor the resulting trinomial. Makes it much easier, and that's the best method, and that's the correct method anyway. So why it is easier to factor trinomials whose leading coefficient is positive? Having them a negative, it becomes a challenge, right? But not to say it can't be solved. It can be solved, but let's get it to a positive. All right, so solution: factor out the negative 1 and then factor the rest. So when we factor the negative 1, this is what happens. Let me use red pen. So we end up with negative h squared plus 2h plus 15. This gives me now negative 1, and we end up with h squared minus 2h negative 15. Now, why did all of them change sign compared to the original problem? Well, because the negative times a positive will give me a negative, and negative times a negative will give me a positive, and negative times a negative will give me back a positive. Okay, and that's what we want. We are not changing the problem, we are just fixing the problem so that we can work with it. Right? Now, we work with the inside problem. Just as how we were doing a while ago, forget about everything else, just worry about that inside piece. Right? This negative 1 is still out there, so we're going to put here negative 1, and we put big bracket. When we end up with this piece here, we will need to work out as if only this you're working with. So let's see. Factors of 15. Negative 15. 1 times negative 15. 3 times negative 5. 5 times negative 3. And 15 times negative 1. And the sum of factors will be what? 1 plus a negative 15, negative 14. 3 plus a negative 5, negative 2. 5 plus a negative 3, positive 2. 15 plus a negative 1, 14. Which one of them gave us the sum of negative 2? Here. So that's a 3 and a negative 5. And 3 times negative 5 gives us back a 15. So therefore, the first term here, we can put here as h and h. I put here now, because that's the combination, plus 3 negative 5. Because 1 is understood to be there, you don't have to write 1, but you need to write the negative, open bracket, h plus 3, close bracket, h minus 5, close bracket, and that's your solution for that particular problem there. Okay, not that difficult. So let's go with our next example like this. So we're going to our next example. We have now factor negative x squared plus 11x minus 28. So the first thing to do is to find the factors of 28. How can I get 28? 1 times negative 28, 2 times negative 14, 4 times negative 7, or 28 times negative 1, 14 times negative 2, or 7 times negative 4. Alright, those are combinations. And then when we find the sum, when we say 1 plus negative 28, we end up with negative 27. 2 plus negative 14, negative 12. 4 plus negative 7, that gives us negative 3. 28 plus a negative 1, 27. 14 plus a negative 2, that will give us a negative, positive 12. And 7 plus a negative 4 will now give us a positive 3. Okay, so then if you notice, working out this way, it complicates the problem to get that positive 11 there. So therefore, what should we do? All right, so we should factor out the negative 1. So now watch what happens to all of our solutions. We factor out the negative 1, so it becomes negative 1 x squared negative 11x positive 28. Right? So we want a positive 28. So when you do this, notice that 28 will be when you multiply two terms which are negatives. So these ones here will give us a negative 28, but we don't want a negative 28, we want a positive 28. So therefore, let's put this one here out, and now let's consider that we are going to look for the factors of 28, which are 1 times 28, 2 times 14, 4 times 7. And now the sum now will be 1 times 1 and 28, 29, 2 and 14, that's 16, 4 and 7, that's 11. Now, which of them, when combined, gives us the middle value? This one here, 4 and 7. but they need to be negatives, because the only way we'll get this to be a negative 11 is that if I say negative 4 plus a negative 7, that will give me a negative 11. And when I say negative 4 times negative 7, that will give me a positive 28. Okay? So you'll see, if you do not factor the negative at the beginning, what this will cause? A lot of confusion. Not to say it can't be solved, it will still be able to be solved, but it complicates it even more. So we come here now, we put negative 1, and we put x and x because we know that's the first term, and we put negative 4, negative 7, and then disregard the negative 1, and we put negative open bracket x minus 4, x minus 7, and that problem is finished. Okay, so we finished with that one there. All right, now let's look at some problems where we have squares at the front and squares at the back. All right, so this is where lots more of multiplication starts to come in. We're going to be factoring out now. We have x squared minus 4xy minus 5y squared. Our strategy here is that we will assume that this is the product of two binomials. That's what we have been finding. And we will use a systematic method to find their terms. Why? Since the terms, these terms do not have a common factor other than 1, the only option available is to try to factor it out as a product of two binomials. That's what we've been doing. This trinomial has two variables, x and y. Notice that very good. Since the first term is x squared, the first term of each factor must be x. That's for sure. All right? So what this is saying is that I already know what is my first term. My first term is x because I have an x squared at the front. That's for sure. All right? Now, for the first term, so to fill in these blank spaces now, we must find two expressions whose product is the last term. Alright, so how can we get this negative 5y squared? And that will give us the middle term, negative 4y. Two such expressions are negative 5y and y. What does that mean? The only way I could get a negative 5 here and a negative 4 is that if I was to say negative 5 times positive 1, that gives you a negative 5, and negative 5 plus 1 gives me a negative 4. So we have the numerical value there. And the only way I could get this to be y squared is that if I put the y's at the back. So this now would become y here and y here. That's the only way I could get a y squared here. And the only way I could get a negative 5y if this is negative 5y and this is positive 1. Because when I say negative 5, because remember this middle term is the sum of these two terms. So negative 5 plus a positive 1, negative 4. 1 times a negative 5, negative 5. Okay? And that's how you get that one there. Okay?